How to identify bias in 99 seconds, let's go. When it comes to identifying bias, guys, the key is going to be to look out for situations in which the probabilities suggested by the experiments are different to the probabilities that we would expect given what we know about those objects. Now, that was all a little bit abstract, so let me make it clear with this example. The question says that Rick flips a coin 250 times and that he gets 190 heads. We're then asked if the coin is likely to be biased based on these results. What do we reckon? Well, we know that a coin should have a 50-50 chance of landing on heads and tails. In other words, there should be a 0.5 probability of getting a heads. Let's calculate an estimate for the probability using these results and see whether it's close to 0.5. If it is close, we probably don't have a biased coin, but if it's a long way away from 0.5, we're probably dealing with a biased object. Let's have a look. So what would the probability be based on these results? Well, we flip the coin 250 times and we get 190 heads, so it would be 190 out of 250. Now we're going to simplify this and write it as a decimal, so it's easier to compare to 0.5. Dividing top and bottom both first by 10, we're going to get 19 over 25. Then we can times top and bottom both by 4, making the denominator 100. We're going to get over 176. Now, this is pretty clearly going to be 0.76 as a decimal. How do we do that? 76 divided by 100 if you're not sure. And then now we need to compare this to 0.5. 0.76, that is very far away from 0.5. So we do have some evidence. We can say, yes, the coin is likely to be biased. Why? Because 0.76 is very far away from 0.5.